Hello, welcome back to the channel. So let's do one more question on solving an indefinite integral using integration by parts. And now this video will be a very interesting video because in this question, we'll cover the concept of solving an indefinite integral using integration by parts, not just once, but we'll use it multiple times in order to solve the same indefinite integral in this case. So in this question, you will indeed realize that whenever you have such type of questions where you have to use integration by parts, there can be some circumstances where you would have to use the integration by parts formula twice or even more than two times in order to calculate the given indefinite integral or definite integral in your question. So now let's try to solve that. We already know the formula, which is basically we take the first function as it is, integration of second minus differentiation of first, integration of second, and integration of the whole second expression. And then if we are calculating an indefinite integral, we'll add the constant of integration at the end. So that is the basic idea about solving an indefinite integral using integration by parts formula, right? So that is why before going over this question, I will highly suggest you to first watch my previous videos on integration by parts so that you can get a good idea about how we are solving this question in this video, and you'll get a very good idea about this video when you would have watched the previous videos in this case. So now again, in order to solve this question, we have to first identify our first function and the second function. And generally the approach that we follow in these type of questions for choosing our first and second function is basically we look for the function we already know an integral for, and then we choose that function as our second function, right? But in this case, we know the integral of x cube and we also know the integral of e to the power x. So we'll have to try both approaches and see what approach would be the best one to solve this indefinite integral in this case. So now in the first case, let's assume our f of x to be x cube. So the first function to be x cube, and let's assume the second function to be e to the power x in this case. And now in order to solve this definite integral over here, we'll use the formula. So first function as it is, integration of second function minus differentiation of first, integration of second, and then the integration of this whole expression over here. We'll simplify this expression quickly so that we can also see the case when we take the first function to be e to the power x and the second function to be x cube in this case. So now let's simplify this equation down, and it would be x cube times integral e to the power x is simply e to the power x. This would be changed to 3x square, right? Because the derivative of x cube is 3x square, and this would be changed to e to the power x, right? So the final expression in this case would become minus 3x square e to the power x dx in this case, right? So now we can see that we originally had x cube e to the power x, and we wanted to calculate the indefinite integral of this expression, and now we have an x square e to the power x expression, right? So now we realize in this case that if we follow this approach, we have rather simplified our expression into a simpler expression than this one, right? And now in order to solve this integral, you'll again have to follow the same integration by parts approach. But the main idea about this expression, which also confirms that we are on the right approach, is that we have indeed simplified our x cube e to the power x expression to a smaller expression over here, right? Which is of the form x square e to the power x expression, right? So that gives us an idea that we are on the right track. Now let's try the opposite case. Let's try our first function. So we want to calculate the integral of x cube e to the power x dx, right? And now in order to solve that, let's assume the opposite case in this situation over here. So we'll assume in this case that our first function is now e to the power x, and the second function over here is x cube in this case, right? And now let's quickly solve this indefinite integral using integration by parts again. So this would be first function as it is, integration of second minus differentiation of first, integration of second, and then integration of this whole expression over here, right? So now let's quickly solve this expression. It would be e to the power x times x to the power 4 upon 4 minus integral this expression, derivative of e to the power x is e to the power x, and integral of x to the power 3 is x to the power 4 upon 4, right? So now over here we will have e to the power x and then x to the power 4 upon 4 dx in this case, right? And now in this case you'll realize that when you assume your first function to be e to the power x and your second function to be x cube, you'll see that if you're using this approach, you are indeed increasing the power of your polynomial function. So in the original expression, it was x cubed times e to the power x, but now you have x to the power 4 times e to the power x. So now if you follow this approach, you are indeed making your calculations even more complex. So when you'll solve this indefinite integral using integration by parts again, by assuming the first function to be e to the power x and the second function to be x to the power 4, you will make an expression which would look like integral e to the power x times x to the power 5 in this case. So that is why it gives us an idea that we should not use this function assumption approach and should rather continue with assuming a first function to be the polynomial function and the second function to be the exponential function in order to simplify our indefinite integral calculations in this case, right? So now we have this expression, but in order to get the final answer, we'll have to solve this expression over here, right? So now let's solve integral x square e to the power x dx, and whatever value we'll get, we'll plug it in this expression over here. So now let's solve for integral x square e to the power x dx. I know you must be thinking that this question would have complex calculations, but the main idea about solving these type of questions is only to identify what you'll choose as your first function and what function will you choose as your second function in order to simplify your integration by parts formula, or the integration by parts indefinite integral in this case. So now we have to calculate integral x square e to the power x dx. Once we have that, we'll multiply it by 3, right? So let's calculate this over here. And now for this expression, we'll use the same approach. I'll do it quickly. So first function as it is. So in this case, similarly, we are assuming our first function to be x squared. We are assuming our second function to be the exponential function over here. And now in order to solve that, we'll do first function as it is, integration of second function, minus differentiation of first, integration of second, and then the integral of this whole expression over here. I solved it rather quickly in this case because at this point of time you might have got the full idea about how we solve integration by parts. So that is why I didn't spend much time on calculating the whole expression and breaking down each parts and then simplifying the final expression. So again, you see that you have this expression over here, and in order to calculate the integral of x e to the power x, we'll have to use the integration by parts formula again in this case, right? So you'll realize in this case that in this question specifically, you are using the integration by parts formula 3 times in this case. So you used your integration by formula over here for the first time, over here for the second time, and this over here for the third time in this case. So now let's again calculate the integral x e to the power x dx in this case. So it would again be, we are assuming our first function to be the polynomial function, the second function to be the exponential function, and then if we simplify this down, we'll get first function as it is, integration of second minus differentiation of first which is 1, integration of second which is e to the power x, and then integration of this whole expression over here. So now when you have this, you'll have your final expression for this integral as x e to the power x minus e to the power x over here, right? We will adjust the constant of integration at the very end when we have the full integral expression over here, right? So now we know that this is our x e to the power x dx integral. This over here is our x square e to the power x dx integral, and this one over here is our x cube e to the power x dx integral in this case. So now we have to calculate this final answer over here, which would be, let's move this down. So this would be x cube e to the power x minus 3 times, let's write the answer for this integral. So it is x square e to the power x square e to the power x, and then you have minus integral 2x e to the power x dx in this case, right? So now let's write the answer to this integral as well, which we already calculated as this one. So we will have x cube e to the power x minus 3 x square e to the power x minus this integral would be twice of x e to the power x minus e to the power x, one bracket, the second bracket which closes this one, and that's it, right? So now in order to calculate the final answer, it would be, and then we will add a constant of integration over here as well, right? Because now we have simplified all the indefinite integrals in our original expression. So we have this expression with no indefinite integral, so that is why we added a constant of integration in this case. Okay, so now let's further simplify this expression over here. So we'll solve this expression, which would be x cubed e to the power x minus 3 times, we'll solve the inner bracket first, so we'll solve this bracket first. So this would be x square e to the power x minus 2x e to the power x plus 2 e to the power x, and then we have a constant of integration at the last, right? And now when we further simplify this expression, it would be x cubed e to the power x minus 3x square e to the power x plus 6x e to the power x minus 6 e to the power x plus c in this case. So this would be your final answer to the integral of x cube e to the power x dx in this case. So that's it for this video, and the most important takeaway from this video is that whenever you are confused about choosing your first function or your second function, always go with following both of those approaches. So in these type of questions, it's recommended to choose all the possible combinations for your first and second function, so that you can clearly see which choice would make your indefinite integral calculation easier than the previous integral calculation, right? So that is why, for example, in this case, we took this assumption first, and then we took this assumption as well in order to confirm that we were indeed on the right track when we chose this assumption rather than choosing this assumption over here. Because in this case, it was complicating our indefinite integral, but in this case, it was indeed simplifying our final answer and our final indefinite integral calculations as well, right? So feel free to comment down in this video if you have any doubts or any specific questions related to any concept. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.